Hello viewers and my dear students. Welcome to the new chapter Plane Stress Analysis. Here I will be showing you a demo on plate with a foil using Ansys release 14. These are all offline video help files prepared by me, that is Dr. B. Gurdat, former professor and head, Department of Mechanical Engineering, Bangalore Institute of Technology, KR Road, Bangalore 4, presently working as professor at the Department of Mechanical Engineering, Nitte Meenakshi Institute of Technology, Yelahanka, Bangalore 64. Okay, now you see here, now in this plane stress analysis, the basics and all that you are supposed to know from FEM. Now what I am telling you is only the basics needed for demonstration. That is, in this lab, that is, in this FEA lab, how to do a given problem in the examination, I am helping you. Plane stress analysis, in general, a thin member subjected to in-plane loading can be considered as plane stress distribution problem or plane stress analysis problem. Okay, now you see here, there is a thin plate, let us say. That is, this is x direction, this is y direction. When compared to x and y, z is this, perpendicular to this plane, okay, perpendicular to x and y, that this is z. That means compared to x and y, z will be minimum. That means z is less. And this is subjected to in-plane loading. That is here, the loading here, the pressure at the ends, you can see that. These are all the examples here, even here also, the thickness is less and subjected to in-plane loading. These are all problems under plane stress analysis. Okay, I have given you some examples. Now you see here, now I am doing one simple problem, stress analysis of a plate. A standard problem from the examination point of view. Many students, even in VTO also, they get the same problem. Plane stress analysis, problem 1, a simple 2D stress concentration problem. Stress analysis of a plate with a foil when subjected to in-plane loading. Okay, that is in-plane loading, plane stress analysis. In the plate with a foil, okay, see here, in the plate with a foil, under plane stress, plot the deformed shape and the stresses on the plate when it is subject to uniform tensile stress of 50 Newton per millimeter square. This is 50 Newton per millimeter square at 2000 Newtons. 2000 Newtons divided by this area, no? This area 40 into 1. Because thickness is 1. This plate thickness is only 1. Okay, 1 mm. In that way, 50 Newton per millimeter square. Okay, and Young's modulus is 210 GPa. Poisson's ratio is 0.3. Find maximum deformation, Vonmises stresses, that is maximum stresses coming up on the structure. Plot the variation of Vonmises stress along the circumference of the foil. These things we'll do as a slowly in different sessions here. Okay. Now you understand this. Here, the first thing what you have to do is what you first have consistency in units. Now here I'm applying the load, pressure load, 50 Newton per millimeter square. Okay. You have either in Newton per meter square or Newton per millimeter square. Since it is Newton per millimeter square, you can have everything in Newton millimeter only. Now this also 210 GPa, no? 210 GPa is 210 into 10 to the power of 9 Newton per meter square. If you convert into Newton per millimeter square, it is 210 into 10 to the power of Newton per meter square. 1 meter is 10 to the power of 3. Meter square is 10 to the power of 6. 10 to the power of 9 minus 10 to the power of 6 is 10 to the power of 3. Or 2.210 into 10 to the power of 3 or 2.1 into 10 to the power of 5. Okay, E will be 2.1 into 10 to the power of 5 Newton per millimeter square it becomes. Okay, please understand this is E is 210 GPa. Newton per 210 into 10 to the power of 9 Newton per meter square. I am converting into Newton per millimeter square, in which case it will be 210 into 10 to the power of 3 Newton per millimeter square or 2.1 E5. Okay. Anyway, this is, you see here. Now, this problem, as you know, you can do by two methods. One, considering the full model. Okay. Considering full model. And since it is symmetrical about x, symmetrical about y, I can take 1/4 of the model and solve the problem. Still you will get the same answer. At least in this session, okay, first I'll consider the entire model and I'll help you how to solve the problem considering the entire model. And I'm not considering any symmetry here. Okay, now this is the problem given. Now assumption is we are assuming plane stress for this analysis as the plate is thin in the z direction, that is 1 mm only, compared to x and y dimensions, and pressure load acts only in the xy plane. Okay, in plane loading is there. That is why we are assuming plane stress analysis or assuming plane stress conditions. Okay, then approaches here in any problem in FEM, you have pre-processing phase, solution phase, and post-processing phase. In the pre-processing phase, we will define element type, material properties, build geometrical model using Ansys capabilities, measure the area after breaking down into number of finite pieces of, and hence convert the geometrical model into finite model. In the solution phase, we'll have assigning the loads, constraints, and solving. In post-processing phase, we'll view and present the different results obtained. That means normally in approach for any Ansys problem will be pre-processing phase, solution phase, and post-processing phase. At least this you remember. Okay. Now we'll start solving this problem. Okay. Now you see here, first what you have to do is file, whatever maybe if somebody has done it, file, clear, start new you do not read file, you say okay. This is the first thing what you have to do. Yes, you say. Okay, and then you say fit. Okay, once you do this, you first thing what you have to do is file, change job name you do. See here, importantly, list log file if you see, so many, that is whatever others created and all that log file would have created. You see, I'll tell you at one particular stage, copying this log file and solving the problem also I'll tell you. Okay, copying this log file. This log file will help in solving the problem. Okay, now what I want is, see here, list log files. I don't want the log file which is created by others. I'll create a fresh log file. That is why what I'll do is file, change job name. Okay, say let us say I'll take Gurudat. Let us say Gurudat 1. Okay, new log and error files compulsorily, yes you say, then say okay. Okay, now whatever I do now for this problem, it will be created in this file. Okay, then file, change title, compulsorily change title. You just say, this is a simple problem, plate, with a full. Okay, just say plate with a fold and just say fit. Plate with a fold has come and your dates will be there when you are created and all that. Everything will know. May 21st, 2020, everything, you'll know the exam timing, everything and all that. Okay. Now plate with a fold. Now if you see, I'm creating a list, log file if you see, here, log file, if you see, you have been created one log file, which I want it to be new. I said no, correct? No. Change job name, I said, change to okay, then file, list, log file. If you see here, if I create, now the log file is fresh now. See here, the screen is fresh. Now whatever I do here afterwards, it will be start recording in the log file only. In the log file only, it will start recording in the log file, and I can copy this log file and paste it in the command prompt, that is the command editor, and I can get the answers also. These things I'll tell you later on. Now I am creating a new log file, that you remember. Anyway, this is done, and now you see here, we'll start with the problem. See here, first we'll go for preferences, structural, you go, okay, you say. Okay, preferences, element type, you go, add, edit, delete, add, you say. Now the quad 4 node 182 element will support our analysis. Okay, that is, when we convert into number of elements, this quad 4 node 182 will support our analysis and will get better results also. That is why choose this only, quad 4 node 182, you choose as an element for this analysis. Okay, okay, then go for options. Then you go plane stress with thickness. Plane stress with thickness option, you go. Just say okay. Then you say close. Okay. Then under real constant, it asks what is the thickness of the plate. Then add. It is plane 182. You remember? That is quad node 182 is plane 182. Say okay. And it will ask the thickness. In this problem, the thickness they are given it as 1. This is 1 mm. Okay. This you should know, it is 1 mm. Okay. Then you say close. Okay. Now you go for material properties, material models, structural, linear, elastic, isotropic. If you go, you see here, I'll give 2.1 E5. Please understand, it is Newton per millimeter square. I have converted it 210 GPa, Newton per meter square, into 2.1 into 10 to the power of 5 Newton per millimeter square. And Poisson's ratio is, I think, 0.3. I'll put 0.3 also. Okay. Just say okay. Okay. And material exit you do. Okay. Then once you do this, you see here, keep saving this. See here, what exactly you have to know here is, I'll save DB. Okay, I'll save DB. See, in Ansys, we don't have this undo command like what you have in Solid Edge or Unigraphics, CATIA and all that. You don't have undo command. Save DB and resume DB will act like undo command. Now I have saved this. That means up till here, that means I have entered the material properties. No, material properties of this plate. This material property is 2.1 E5 means it is obviously steel. Steel material property I have entered. Okay, up till here it is saved. Let us say now, please understand, up to material properties 2.1 E5 and Poisson's ratio 0.3 and all that I have entered. Up to that it is saved now. Okay, later on in modeling, no, in modeling, in case I make a mistake, what in the exam also, let us say you make a mistake, then you just say resume DB. Okay, resume DB means it will go to that particular level where you had saved earlier. That means you had saved at element type, no, that is material properties you had saved. You go to that, then you again start doing. Okay, whatever you had created mistake in modeling, that will go off and it will go to the stage where you had fed that is material properties. This you please remember. Okay, if you remember this, the things will be pretty easy for you to do. Okay, now it is the end of session 1 on plate with a hole analysis. We'll continue this in session 2. Thanks friends. Thank you very much for watching. Thank you.